we're talking about 14.1 right now, so I'll read the problem. O is a point equidistant from parallel lines L1 and L2. And so there's point O. It's equidistant from parallel lines L1 and L2. So when we say equidistant, we're talking about this line here, this perpendicular here, and this perpendicular, this line going through L, equidistant from both of those. Because we know how to go from a point to a line, you just have to drop the perpendicular. So O is equidistant from parallel lines L1 and L2, and a mapping M maps each point P of L1. So I'm going to take any point, a garden variety point P on L1, and it's going to go to a point P prime where PO intersects L2. So how many points determine a line? 2, right? So here's your point P, here's your point O, and we're going to continue this line, and wherever this line PO intersects line L2, that's where P prime is going to be. All right. So because point O here is equidistant, this distance here from P to O and from O to P prime is going to be the same. And so let's take another point Q here. From Q to O, that's going to be the same distances from O to Q prime. Now, the first question is the mapping a one-to-one mapping of L1 onto L2? And so 1-to-1 means every P has a P prime and every P prime has a P. And you can see that that's the case. All right, so yes, it is a one-to-one mapping. Does this mapping preserve or distort distance? In other words, we want to know if PQ is the same distance as P prime Q prime. So if we know that PO and OP prime are both congruent and QO and OQ prime are both congruent, these angles here in the middle are always going to be the same because they're vertical angles. Therefore, these triangles are congruent. Because the triangles are congruent, PQ is going to always be congruent to P prime Q prime. And so it preserves distance. It does not distort distance. That's part B. Part C says if lines L1 and L2 were not parallel, would the mapping preserve distance? Now, I'm not going to do a formal proof, but I'm just going to show you a picture here that I've drawn. Okay. So, you know, this distance here from O to this line here, you know, there it is. But it really doesn't make sense if the lines aren't parallel that I can talk that O is in the center of the two lines. It doesn't make sense. All right? And so versus here, this point O here, when the lines were parallel, you know, O was on a third line that was parallel to both of them. And then we could talk about the distance from O to L2 being the same as the distance from O to L1. But that just doesn't make any sense. I can't get a line, since neither of these two lines, L1 or L2, are not parallel. I can't get a line that's equidistant from both of them because the angle of the line changes. So even though these angles right here are going to be the same, I can't say that QO and OQ prime are the same, and I can't say that PO and OP prime are the same. So I don't get two congruent triangles, and therefore PQ, that's the distance. I want to know, is that the same as the distance P prime Q prime? No, it is not. I could probably do this proof by indirect method, but at this point we're not that formal. Okay, so that's 14.1, problem number 11.